Okay, so we have a set of questions on the doc. Because we have enough time, then we can go around the room if needed. So the first question would be, do you think verification correctness tools have enough adoption in industry, or is more an academia kind of thing?
I think, so having very recently graduated and having run the gamut of interviews, I think something that really struck me when I was going and talking to different companies is the desire to reach out to tools like Jepsen to develop in tandem with them. You know, as you implement different changes and before you push out releases, being certain that things work as they expect, since it's a very contentious area. And seeing large-scale, large-scale systems operators really focus on that because they want to retain trust. Trust is something that's incredibly hard to win back once it's lost, and a good way to lose it is somebody exposing flaws like that in your system. I think that, you know, weaving that into your development process is really wonderful. They're getting more mature, and I'm seeing them pop up. I've seen more companies ask me about them as I've kind of been poking my nose around. And I think that they're getting to a point where they are maturing. I think that it's something that is not just in academia and is kind of starting to bleed into history, or bleed into industry. And it's something that we should examine. If trust is that valuable, you really want to know what you're using to give you the perception of trust.
Cool. Second question, could it be possible to extend this type of method to cover other type of distributed system, not only databases?
I suppose so. I think at least the approach of, you know, how you would build tests like that, how you would classify that space, what kind of faults you encounter, and then really centering on, you know, it becomes more of how you digest that problem. You know, in distributed systems, there's this really large, like, you ask the question of, you know, title of the talk, like, what can possibly go wrong? It's this enormous combinatorial set of things. And if there's some kind of common pattern that you can look for, if there's some way that you can classify what's going wrong, you can start to find ways to confound it and make it more difficult while still retaining that quality. They're all kind of isomorphic issues. I don't see why not.
Cool. And the last question on the doc is, could tracing be used to generate histories based on real data?
Yes, I think so. So that was something that we discussed back in option 2. I don't recall if the slides were working or not at that time. But one could certainly create these kinds of traces from real histories. I would still advise maybe, so if you want to do that for a specific system and discover your specific weaknesses, that's wonderful, but you may have blind spots for different areas. You risk, you know, not covering other cases, and so you want to cover bases, even ones that you currently succeed with. You know, this kind of becomes like a regression test sort of deal, where you might pass it now, it might be fine, but if you don't have examples of it not passing, you don't have them when you implement those tests, you know, going forward, you're not going to have a case like that to cover. And so really trying to, I think it's fine to start with that as a route, but really enrich the testing environment that you have, the set of test cases.
Fair enough. That's it in the doc. Any other questions? Yep, okay.
You're talking about the right conflict, but isn't that supposed to be prevented? Because otherwise, if you have it, you cannot provide the
If you can repeat the question for the video, yeah.
Please.
Thank you. Yeah, my question is about right conflicts. How is that supposed to work, or how can you catch it in the database system? Because if you have a right conflict, then you cannot even have atomicity, because you cannot guarantee rolling back to something that was stable. So how I don't know, what database was a multi-master database or something like that, or how? And you could change rows in multiple nodes, and they have to be merged at some point during commit.
So, oh, thank you. So there are these transactions which will have these contesting rights. And so what it is we're looking for something that'll give us, you know, the same kinds we're looking at view serializability, so we want the equivalent effects. And so having these right conflicts, you know, as long as we wind up at the correct state, are we okay? And so it is still possible to run into these kinds of things. If you've got them buried deep down, they can be kind of easy to miss. They're the easiest to confound or turn into other things. And so I think they're easy to prevent, but there's still something that can come up in different systems, and it's not a case that I would want to overlook, because if I assume like, oh, that won't happen, it's going to be catastrophic if and when it does, and I'm happy to include it as a test case. Thank you.
There was another question at the back.
Hello. Yep. Just a moment, I can't hear you.
Can you hear me now?
Yes.
Yeah. I was saying that great talk, thank you.
Thank you.
The question is, my understanding is, correct me if I'm wrong, is that the problem with commercial database software is that the license agreement doesn't allow to publish results of testing like Jepsen, and that's the reason why Kyle's been testing like open source databases. So what's the latest there? Is it changing? Has it changed? Can you run Jepsen and publish something against Oracle or SQL Server? From the legal perspective.
Okay, so it was a little bit muddled in the audio towards the end. I did hear it is a legal question, and I am no lawyer. Can you repeat the central part of your question?
My understanding is that you cannot publish legally today benchmarks like this against commercial software. So is that changing? Is there any kind of way to do that?
I can't speak to that. I don't think I would feel comfortable speaking to that, no.
Okay, thank you.
Thank you, Sergey.
Any other questions? Yep.
Hi.
Hello. So in SQL, you can get interesting constructions where you might do a read and a write within the same command. So like you can have a select, which is just a read, but you might have an update where where that condition implicitly reads the current state of the database and then possibly writes something based on that. Do you notice any difference when you're generating these kind of test patterns of transactions, any difference between these kind of only reads and these operations that mingle a read and a write together?
So let me stay close because I'm going to ask a clarifying question. So when you talk about mingling them, do you mean a transaction that includes those reads and writes that nests them as a series of operations in that transaction, or do you mean in terms of like a conflict edge?
I don't know exactly what I mean. I just observed when I did some tests myself that a database may handle the case of an explicit select differently from a read that happens as part of an update. And so, although from like a formal perspective, it might be like represented as a read of the same register in a named register in a database, it may actually be implemented quite differently internally and thus trigger different code paths and thus potentially trigger different bugs.
I see. Okay, I think from where I was standing, those were treated very similarly. I think were it to be expanded, so like in the future work, I think giving coverage for those different predicates, things like that, I think it would absolutely be handled differently, but for right now, from the perspective of view serializability, they're treated very similarly as just reads of the same register. Okay, are there any other questions?
Okay, thank you very much.
Thank you all very much.